Class 10th, Subject Science, Chemical Reactions and Equations. Page number 6. Exercise 1.2. Types of Chemical Reactions. We have learnt in class 9 that during a chemical reaction, atoms of one element do not change into those of another element, nor do atoms disappear from the mixture or appear from elsewhere. Actually, chemical reactions involve the breaking and making of bonds between atoms to produce new substances. You will study about types of bonds formed between atoms in chapter 3 and 4. 1.2.1 Combination Reactions. Activity 1.4. Take a small amount of calcium oxide or quicklime in a beaker. 2. Slowly add water to this. 3. Touch the beaker as shown in figure 1.3. 4. Do you feel any change in temperature? In figure 1.2, formation of slacked lime by the reaction of calcium oxide with water is shown. Calcium oxide reacts vigorously with water to produce slacked lime, that is calcium hydroxide, releasing a large amount of heat. CaO plus H2O is equal to CaOH twice plus heat 1.13. In this reaction, calcium oxide and water combine to form a single product, calcium hydroxide. Such a reaction in which a single product is formed from two or more reactants is known as combination reactions. Page number 7. A solution of slacked lime produced by the reaction 1.13 is used for whitewashing walls. Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the wall. It is interesting to note that the chemical formula for marble is also CaCO3. CaOH2 calcium hydroxide plus CO2 is equal to CaCO3 plus H2O. 1.14. Let us discuss some more examples of combination reaction. First one, burning of coal. Calcium plus O2 is equal to CO2. 1.15. Second, formation of water from H2 and O2. Twice H2 plus O2 is equal to twice H2O. 1.16. In simple language, we can say that when two or more substances, elements or compounds combine to form a single product, the reactions are called combination reaction. In activity 1.4, we also observed that a large amount of heat is evolved. This makes the reaction mixture warm. Reaction in which heat is released along with the formation of product are called exothermic chemical reactions. Other examples of exothermic reactions are: first, burning of natural gas. CH4 plus twice O2 is equal to CO2 gas plus twice H2O gas. 1.17. Second, do you know that respiration is an exothermic process? We all know that we need energy to stay alive. We get this energy from the food we eat. During digestion, food is broken down into simpler substances. For example, rice, potatoes and bread contain carbohydrates. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cells of our body and provides energy. The special name of this reaction is respiration, the process of which you will study in chapter 6. C6H12O6 plus 6O2 is equal to 6CO2 plus 6H2O plus energy. Third, the decomposition of vegetable matter into compost is also an example of an exothermic reaction. Identify the type of reaction taking place in activity 1.1, where heat is given out along with the formation of a single product. Now page number 8. Decomposition reaction. Activity 1.5. Take about 2 gram ferrous sulfate crystals in a dry boiling tube. Second, note the color of the ferrous sulfate crystals. Third, heat the boiling tube over the flame of a burner or spirit lamp as shown in figure 1.4. Fourth, observe the color of the crystals after heating. In figure 1.4, correct way of heating the boiling tube containing crystals of ferrous sulfate and of smelling the odor. Have you noticed that the green color of the ferrous sulfate crystal has changed? You can also smell the characteristic odor of burning sulfur. Twice FeSO4 on heating Fe2O3 plus SO2 plus SO3. This is equation 1.19. In this reaction, you can observe that a single reactant breaks down to give simpler product. This is decomposition reaction. Ferrous sulfate crystals FeSO4, 7H2O lose water when heated and the color of the crystal changes. It then decomposes to ferric oxide Fe2O3, sulfur dioxide SO2 and sulfur trioxide SO3. Ferric oxide is a solid while SO2 and SO3 are gases. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called lime or quicklime. It has many uses. One is in manufacture of cement. When a decomposition reaction is carried out by heating, it is called decomposition. CaCO3 limestone on heating CaO quicklime plus CO2. This is equation 1.20. Another example of a thermal decomposition reaction is given in activity 1.6. Activity 1.6. 1. Take about 2 gram lead nitrate powder in a boiling tube. 2. Hold the boiling tube with a pair of tongue and heat it over a flame as shown in figure 1.5. 3. What do you observe? Note down the change if any. In figure 1.5, heating of lead nitrate and emission of nitrogen dioxide. You will observe the emission of brown fumes. These fumes are of nitrogen dioxide NO2. The reaction that takes place is page number 9. Twice Pb NO3 twice on heating twice PbO lead oxide plus 4NO2 nitrogen dioxide plus O2 oxygen. This is equation 1.21. Let us perform some more decomposition reaction as given in activities 1.7 and 1.8. Activity 1.7. Take a plastic mug. Drill 2 holes at its base and fit rubber stopper in these holes. Insert carbon electrodes in these rubber stopper as shown in figure 1.6. Second, connect these electrodes to a 6-volt battery. Third, fill the mug with water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. 4. take two test tubes filled with water and invert them over the two carbon electrodes. Fifth, switch on the current and leave the apparatus undisturbed for some time. 8. You will observe the formation of bubble at both the electrodes. These bubbles displace water in the test tubes. 9. Is the volume of the gas collected the same in both the test tubes? 10. Once the test tubes are filled with the respective gases, remove them carefully. 12. Test these gases one by one by bringing a burning candle close to the mouth of the test tube. Question. This step must be performed carefully by the teacher. What happens in each case? Which gas is present in each test tube? In figure 1.6, electrolysis of water has shown. Activity 1.8. Take about 2 grams silver chloride in a china dish. What is its color? Place this china dish in sunlight for some time, as shown in figure 1.7. Observe the color of the silver chloride after some time. In figure 1.7, silver chloride turns grey in sunlight to form silver metal. You will see that white silver chloride turns grey in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. Twice AgCl on giving sunlight is equal to 2Ag plus Cl2. This is equation 1.22. Page number 10. Silver bromide also behaves in the same way. Twice AgBr on giving sunlight is equal to twice Ag plus Br2. This is equation 1.23. The above reactions are used in black and white photography. What form of energy is causing these decomposition reactions? We have seen that the decomposition reactions require energy either in the form of heat, light, or electricity for breaking down the reactants. Reaction in which energy is absorbed are known as endothermic reactions. Carry out the following activity. Take about 2 gram barium hydroxide in a test tube, add 1 gram of ammonium chloride and mix with the help of a glass rod. Touch the bottom of the test tube with your palm. What do you feel? Is this an exothermic or endothermic reaction? Questions. A solution of substance X is used for whitewashing. 1. Name the substance X and write its formula. 2nd. Write the reaction of the substance X named in 1 above with water. 2nd question. Why is the amount of gas collected in one of the test tube in activity 1.7 double of the amount collected in the other? Name this gas. 1.2.3 Displacement reaction. Activity 1.9. Take 3 iron nails and clean them by rubbing with sandpaper. Take 2 test tubes marked as A and B. In each test tube, take about 10 ml copper sulfate solution. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for about 20 minutes. Keep 1 iron nail aside for comparison. After 20 minutes, take out the iron nail from the copper sulfate solution. Compare the intensity of the blue color of copper sulfate solution in test tube A and B. Figure 1.8. Also compare the color of the iron nails dipped in the copper sulfate solution with the one kept aside. Figure 1.8. In figure 1.08, iron nails dipped in copper sulfate solution.